All right, so this one is very similar to that last example, the one dealing with cosines. So I'm going to say, I'm going to pretend that u is equal to sine of x, make my little substitution. All right, this would mean that that is u to the second power. This would just be a u, and then minus 2. So I'm going to factor this like I would a regular trinomial. So I need the factors of negative 2 that will add up to give me the 1, positive 1 here. So it's u and u. Let's see here. I know that it's got to be a 2 and a 1. That's the only way to get it 2. And I know they're different signs. Let's see here. Okay, so the sign of the bigger number in this case has to be positive. Let me double check this, make sure. All right, this would be negative 1. This would be positive 2. And that does add up to be positive 1. So this checks out. All right, let's put my signs back into place. So we've got sine of x. We're replacing that u back with the sine of x. Okay, and then sine of x minus 1. Okay, and then we're going to take these factors and then set them each individually to 0. Let me do this one first. So sine of x minus 1 is equal to 0. I need to move that 1 to the other side. All right, so I'll scratch that out. Put the 1 there. All right, I added 1 to both sides. Now, for sine of x to equal 1, let's see here. It only occurs in one position. The only time that sine of x is equal to 1 is at 90 degrees, or pi over 2. All right. So x has to equal that value, plus or minus 360. Now for this one, this is the reason I made this video. This one's a little different. Sine of x plus 2, if I set that equal to 0, all right, subtract 2 from both sides. This right here is outside of sine of x's range. Regular sine of x never actually reaches negative 2. So if you remember our definition for sine of x with the right triangles, it was always opposite over hypotenuse, and the hypotenuse is always bigger than our opposite side. So that meant that this value right here always had to be less than 1. But then we talked about the unit circle, and it is possible for sine of x to equal 1. Let me jump over here on Desmos just to refresh you a little bit on y. Okay, so here on Desmos, in red I've graphed sine of x, and in the blue I went ahead and graphed the negative 2. And I just want to show you again, because the negative 2 never actually intersects with the sine graph. So remember, sine, it always oscillates between positive 1 for y and negative 1. Those are the max and min that it ever reaches. Now that's for regular sine of x. So right now we're still talking, basic trig equations. If I was to change this to a 3, then they would intersect. All right, it kind of changes the graph. But so for that one, that factor by itself would have no solutions. Right? So this would be the only valid solutions for